All right, so example 1, we are converting rectangular equations to polar equations. So y equals 6 is a horizontal line when y is 6, okay? If we remember our conversions, y is the same thing as saying r sine theta. So this is the same as if I write polar, instead of y, I write r sine theta equals 6. And we want to solve for r. So r will equal 6 over sine theta. And you can either leave it like that, or if we don't want a trig function in the denominator, remember that is the same thing as saying if I can write, sorry about that, cosecant theta, okay? So either of these answers are fine. Okay, really, I'd probably just take this one. It's the easiest, so you don't mess up with your trig functions. Okay, so for the second one, I need to replace x and y again. So if I leave the 4 in front of the x, but x is r cosine theta, minus 2, y is r sine theta, minus 1 equals 0. So let's simplify some things. Let's see. I end up with 4r cosine theta minus 2r sine theta minus 1 equals 0. Actually, let's move that 1 to the other side. So let's have it equal positive 1. There we go. Now, I can factor some things out of this left side. I can take an r out of everything and a 2 out of everything. But do I want to do that? No, I just want to solve for r. So I'm just going to take r out of everything, okay? We want to get r by itself. Oops, it's not equal. Okay. So if I take an r out of 4r cosine theta, I'm left with 4 cosine theta minus 2 sine theta equals 1. Because remember, our polar equations are r equals. All right. Rectangular equations, we usually see them as y equals, or they just have an x and a y, no powers and stuff like that. But polar equations are y equals. So we're always solving for r. So, whoops, in my parentheses there. Sorry about that. So to get r by itself, it is multiplying 4 cosine theta minus 2 sine theta. So if it's multiplying it, to move it to the other side, I must divide by it. So r equals 1 over 4 cosine theta minus 2 sine theta. It was dividing by all of it. Okay? All right, I solved for r. Now, you could rewrite this with 4 secant theta minus 2 cosecant theta, but this is fine. Just having it, we solve for r. r equals, there we go. All right, now this last one, it is in the equation of a circle. So we are going to convert it. And we can do this a couple of ways. Yes, we can substitute in r cosine theta for x and r sine theta for x. But we also know an equation that is x squared plus y squared equals r squared. Okay? Well, I have x squared plus y squared, so that means 25 is r squared. If I have r squared equals 25, and I square root both sides, I get plus or minus 5. Okay? That's it. Done. Now, if you would have substituted in, I'm just going to show you just in case you want to do that. If you don't want to do that, you can stop this video, move on to example 2 on the next video. But I will do it just for those that want to see this. R cosine theta squared plus r sine theta squared, equals 25. So I have r squared cosine theta squared, this is where the squared goes, plus r squared sine squared theta equals 25. Take r squared out of both things. This is an identity. Cosine squared plus sine squared is 1, so I have r squared times 1, which is just r squared. and we end up with that same bit right there. Okay, so either way you do it, you should get down to the same piece. All right, go on to the next video and example 2.